Professor Danielsson, member of the Nobel Committee for Physics. This year's Nobel Prize is twofold, so let's start with the first part about the universe. What did you award?
Sorry?
What was the award about?
The award was about really this discovery of the universe, in a sense, the whole history of the universe and the contents of the universe. And James Peebles is one of the most important cosmologists of our time, and he has contributed to several really essential pieces in this puzzle. So it's about really to realize what our universe consists of. It's not only ordinary matter, the thing that we sort of experience in our daily life, but there are also other unknown dark components. 95% of the energy of the universe is really basically unknown. We just know some of its properties. That is the dark matter and it's the dark energy. And James Peebles have revealed how, by looking back in time towards the Big Bang, looking at the cosmic microwave background radiation which had been traveling to us for almost 14 billion years, how you in that radiation can read off basically the contents of our universe.
That is mostly unknown.
It's mostly unknown. We know the properties, the general properties of this. The dark matter is sort of like matter. It's in clump and it can form gigantic clouds around the galaxies. We know it's there through its gravitational influence on other matter, and also in the early universe when the dark matter had to be there in order for galaxies to form in the first place. But we don't know what that dark matter actually is. And then there's the dark energy, which doesn't really clump, it's spread uniformly through the universe, but it has the property of accelerating the expansion of the universe. So the galaxies are moving ever faster away from each other, but again, we know it's there. We know that it dominates the energy of our universe, but again, we don't know what it actually is.
What metaphor would you use to describe the universe?
Well, one metaphor that I really liked, which I also used in the presentation, is to compare with a cup of coffee. Then, I mean, most what you have in the cup of coffee is, of course, the coffee itself. That's the dark energy. I think that's a very nice parallel. Dark energy, that's the coffee in the cup. But it's not only that. You also need to have some cream or milk. Quite a lot, not as much as the coffee, of course, but still a fair amount of that. That's the dark matter, like a quarter or so. And then just a tiny little bit of sugar. That's the ordinary matter. That's what makes the universe sweet, in a sense. That's us, that's the stars, that's the planets. And then you have to stir a bit, and that's your universe.
Yes. And in this sweet universe, we have planets?
We have planets, indeed.
That takes us to the second prize, part of the prize. What was it about?
That's about the discovery of the first planet in orbit around a solar-type star. So it's really the first planet which you could sort of compare with our own solar system. It's sort of the first example where we're really trying to see how does other solar systems look like. So the star in that system was very similar to our own sun. But the big surprise was that this first other planetary system was so different from our own planetary system. We had thought that all planetary systems would sort of look the same, like our solar system. But in this system, it turned out that there was a big planet, as big as Jupiter, but it was so close to its sun that it took just a few days for it to go one orbit around the sun, while Jupiter takes like 12 years and the Earth obviously 1 year. So it's extremely close, which means that it's also very, very hot. So it's a solar system, a planetary system, very different from ours. And since this first discovery, one had discovered many different kinds of planetary systems. So it's a very rich and varied universe out there, full of planets actually. I mean, there might be billions of planets in our own Milky Way.
And why was it so hard to find if it was so big, the first planet?
Well, the planet is big, but the universe is also big, and stars are quite big. So first of all, a planet that close is very, very difficult to see because it's hidden in the light of the star. On the other hand, it's easy to see because it's close for another reason, and that is that the planet is certainly orbiting around the star, but the star is also moving a little bit. They are moving around the common center of mass, so the star is also wobbling a little bit back and forth. And then if you look at the star and carefully measure its color, there are techniques to do that, you can see that the star is actually moving back and forth along the line of sight. And if you can measure that, then you can calculate the effect of a planet. And you can see that it's a planet which is doing that. So through that wobbling motion, you can detect the motion of a planet around the star. That was the technique used in this particular case.
So you actually don't see any planet?
You don't see the planet, you just see the effect of the planet. Then since then, there are other methods which have been developed, where you instead look at the star, and then if you're lucky, the planet will be orbiting in front of the star, and then you can see a little bit of a dip in the light curve. And this is a method which has been used over since then to discover a large number of planets. So there are basically these two different methods to detect planets, but in neither of them you directly see the planet, just its effect on the light from the star.
Do you think we will ever find life outside there in the space?
Well, I would say that these kind of discoveries now is certainly a step on the way to figure out how it really is, if there is life or not. We now have a chance to actually not just speculate, but go out and observe and try really to establish how it is. Because in the future, and it might be actually quite near future, we will be able to, particular perhaps with planets which are moving in front of the stars, we could be able to measure and detect the atmospheres around such planets, and then to see whether there are, what kind of gases there are, whether there are oxygen or water, vapor, and so on and so forth. And in this way, we could take further steps to see whether there actually is life out there. Me personally, I think there is somewhere.
Let's talk a little about the Nobel laureates. Michel Mayor and Didier Queloz are the two who get the prize this year. Did they work together, or did
they work together on this particular discovery? So they are really, it's a joint discovery with these two scientists. So there is a key paper where they discuss this discovery, and that is these two together.
And finally, my question would be, if you had 30 seconds to say, what makes you most excited about this year's Nobel Prize?
I think it's really a common theme in both these prizes, because they really sort of tell us something very essential, existential about our place in the universe. I mean, the first one with cosmology, the history back to an unknown origin, it's so fascinating. And the other one, I mean, it tries to answer these questions about, are we alone? Is there life anywhere else in the universe? It's really about our place in the universe, both of them.
Thank you, Danielsson, for taking your time.
Thank you.